In this calculator tutorial, I'd like to show you how to find the intersection of two graphs, and in doing that intersection of two graphs on the calculator, I'm going to illustrate using this technique to verify a solution of a system of linear equations. Over here on the left side of the screen, you can see that I have two equations that are linear, and the directions of this problem might say solve the system of equations or solve the system of linear equations. A couple techniques in which I can do that analytically by hand. One of them is the substitution method, the other one is the addition method, and that's the method that I'm going to use. So what I'm approaching here is the idea that if I add these two equations together, the x's will cancel out, or in other words add to 0, and I will be able to solve for y. So down here in this step, I'm actually adding together, even though you don't see a plus sign over here. That really is what I'm doing, is adding together the zeros. The x's become 0. I get 5y equals negative 5. And then at this line, I'm dividing both sides by 5 to solve for y. So in solving the systems of equation, I'm finding out that if y is negative 1, the system is satisfied. But I also need to find the x value that goes with that. So I'm taking the second equation here, in essence, where I've divided everything by 2 to produce this equation. So taking the second equation and just reducing the equation, dividing both sides by 2. And then taking the y value that we found and plugging it in here for the y and solving for x. We find out that if x is 2, y is negative 1 is the solution to this system. And down here I'm saying the solution is the point xy, or 2, negative 1. So over here on the right hand side, what I'm going to do is graph both of those equations. So the first equation I'm solving for y and plugging that into y1. The second equation I'm solving for y and plugging that into y2. And then if I do, let's say, a zoom standard window, zoom 6, I get this picture here. And I can see roughly that if x is 2, y is negative 1 is the point of intersection. Okay, that's the point that satisfies both lines. And again, graphically, that's what that means. When we're solving a system of equations, we're finding the point that lies on both lines, or both equations, graphically. Now, what I want to do, let me do a zoom decimal here. I'll do a zoom decimal. Zoom decimal. To get a little better of a picture here. Okay. Computer's running a little slow. Please bear with me here. So here's the zoom decimal, and I can see even better 2, negative 1. That definitely looks like the solution, but I want to go ahead and have the calculator find that for me. So above the trace key in the calc menu, I'm going to do second trace, go to calc, and you'll notice number 5 is intersection. So I'll just punch number 5 and find the intersection. Basically, it's going to ask me for 3 things. It's going to give me the blinking cursor here, and it's going to say trace along your first curve to put the blinking cursor near the intersection point. So here's the blinking cursor. I need to move it to the right. So I'm going to hit the right arrow until I get it, as close to the intersection as I possibly can. Doesn't have to be exact. And you know what, just for fun, let's do this. Let's go to zoom standard and do this all over again. Because in the zoom decimal window, I'm going to get exactly to the intersection point. And I don't really want to do that. So let's redo this. So along the first curve, I'm going to trace and get about as close to the intersection as I can. You notice I don't get exactly to x equals 2. But in the zoom decimal window I would have. So anyway, so I'm back in the zoom standard window. I'm as close to the intersection as I can get. Hit enter. And then it says second curve. Move your blinking cursor along the second curve. And notice how the blinking cursor is almost already there. I usually never have to move it for the second curve, but I'm going to back off here for a second just to show you. I'm now on the second curve. I'm going to move to the intersection as close as possible. Hit enter, and then now it wants a guess. So already the blinking cursor is pretty close to the intersection. I'm going to say there's my guess, and there's my intersection point. So the solution to this system graphically is the point x equals 2, y equals -1, and that would be how we find an intersection of two curves, in this case 2 lines.